Good evening, students. Welcome to what I think might be your last video in Chapter 4. We are going to be discussing the coolest application of quadratics, which is projectile motion. So the essential question, what is this? The coolest possible topic in all of quadratics. You will get into this more when you do physics later on in your life. And yes, quadratics, very cool. So projectile motion, here's the formula. You have seen a part of this formula before, this. You have seen h equals negative 16t squared plus h sub 0. Remember that h is the height at a given point time, and in this case, height is in feet and time is in seconds. You know that h sub 0 in our free fall equation meant the initial height. However, our free fall equation was a bit limited, and that is because it assumed that you were dropping an object. But what if you are starting the object at some sort of initial velocity? In other words, what if you throw the object or launch the object, or instead of just dropping the object, launch it at the ground? In other words, what if you also, in addition to your initial height, have an initial velocity? So that is what makes projectile motion different than free fall. Free fall is a sort of projectile motion where there is zero initial velocity, but today we are going to be dealing with a problem where there is initial velocity. Here is the problem. One of my least favorite parts of teaching is dealing with talkative students. So example 1, I am mad at a student for talking in class, and I want to exact my revenge. So I take a cannon and I put it on top of a building, and I launch this student upwards at an initial velocity of 30 feet per second from the top of a 100-foot tall cannon. This problem, we are going to do some stuff. We are going to analyze it. I want to see exactly how long this student is going to be flying, how high they will be flying, and so forth. First of all, it would probably be a good idea for me to write the formula that applies to this situation. Notice that we have our initial velocity. We also have our initial height. So this 30 feet per second squared is my v sub 0. This 100 feet tall is my h sub 0. So let's plug that into the formula. H equals negative 16t squared plus 30t plus 100, and I am going to be doing some stuff. So first of all, let's put this into our calculator in the y equals menu. I already have the negative 16x squared in for my free fall, but this time I'm adding 30x plus 100. Now, let's look at the table first, because the table is going to give us an idea of what I need to scale my graph at. So let's just make a table, and it looks like, let me just reset my table so that it goes by ones. Okay, so here's my table. So at a time of 0, I am starting at a height of 100. And that should make a lot of sense, right? That was our initial height. 100 was our initial height. At 1 second, I'm getting up to 114 feet. At 2 seconds, I'll be at 96. At 3 seconds, I'll be at 46. And then we notice at 4 seconds, I've gone negative. So remember, somewhere in between 3 seconds and 4 seconds, I'm getting to a height of 0. In other words, somewhere in between 3 and 4, I'm hitting the ground. So let's plot these points on our graph. It looks like I can scale my axis like this. And I will draw a quick sketch for now. Let's scale our axis. Maybe we should go by like 20s, 20, 40, 60, 80, 100, 120. I don't know exactly where the vertex is right now. We will be getting up to around there and then coming back down. I'm just plotting points on the graph for now, and I'm wasting time by talking. But anyway, okay, and we hit the ground somewhere in between 3 and 4. This is a relatively sketchy graph by now because I do not know the vertex yet. But let's find the vertex. I can go into my graph. Let's first adjust the window. Definitely my x max, 0 to 5 would be fine. I could even go 0 to 4. For the y minimum, 0. And it looks like I'm going up to a height of at least over 114. Let's put it at 130 and look at my graph. I should get a nice parabola. There we go. Now, the parabola, remember what this represents. If I look at the graph, I can see at what height the student is at different points in time. So look, at 0.5 seconds, I would estimate the student is somewhere around 110. We know that at 1 second, they're exactly at 114. We know that at 2 seconds, they're exactly at 96. So this graph tells us for different times what is the height of the student. But I need to be more exact. Let's find the vertex and let's talk about what the vertex means. I'm going to show you a function. It is second calc. If you do maximum, which is number 4, that will tell you the vertex because that's the maximum here. I need to adjust my cursor. It's asking for a left bound. So let's go to the left of where I think the vertex is. So maybe somewhere over here. Then we can go to the, I cleared it, darn it. Okay, let's try that again. Maximum, left bound, that looks good. Right bound, let's go to the right of where I think the vertex is, maybe there. And then my guess, I need to be right on where the vertex is. Let's go there. All right, so it looks like the maximum value here, my vertex is at 0.94, let's say, 114.06. Okay, now let's talk about what this vertex means in the context. Remember, t is the time, h is the height, and this is the maximum, right? So the maximum height the student will reach is, the maximum height is up at 114. So something I know about this student's trajectory, the maximum height is going to be 114.06 feet. Excellent. And this will occur at the time t equals 0.94 seconds. So if I'm trying to inflict maximum psychological pain on this student who I was annoyed at, do I think 114 feet into the sky is fine? Sure, that seems high enough. Another thing that I want to know about is when will the student hit the ground, because I want them to be in the air for the maximum possible time, contemplating their fate. So in other words, I want to find what time they hit the ground. Let's solve for the 0. We have seen the 0 before. So second calc, 0. I need to give it a left bound. And so again, I'm going to spend a ton of time hitting to the right because I need to get my cursor over to the left of the 0. Remember, in the context of free fall, the 0 is how much time does the person take to hit the ground. So there's my left bound. My right bound, I'll put somewhere over to the right. It's off the graph. The guess, I'm going to put, yeah, that looks close enough. My cursor's basically right on the x-axis. Hit enter. It looks like my 0 is at the point 3.61, 0. So that means they will be in the air. Whoever this student is, they will be in the air for 3.61 seconds. After which point they will hit the ground, hopefully learning their lesson about talking in class. One last thing that we can maybe say about this function is just some domain and range things. It's always good to talk about the domain and the range. Keep in mind, the domain is all of the times that make sense in the context of this problem. I don't go any lower than 0. I don't go any higher than 3.61. No lower than 0 because I'm not going back in time. That doesn't make sense. No higher than 3.61 because if I go past a time of 3.61, that is like the student has already hit the ground. It doesn't make sense to go past 3.1. Let's talk about the range. 0, when they hit the ground, is obviously the lowest point. The highest point here, though, is not the initial height like it was in free fall. Since I'm initially throwing the student up, actually the maximum height is this vertex. The maximum height they reach is 114.06. I should probably put 0 seconds, 3.16 seconds, 0 feet, 114 feet. All right, here's the last thing I'll say, and then you're done watching the video. I could also do a free fall where instead of launching the student up, maybe I'm just super frustrated and I throw them at the ground. If I threw them at the ground, wouldn't that be a negative velocity? Here I'm launching the student up, and so my initial velocity is positive. If we think about throwing a student down into the ground, my initial velocity would be negative. So just know, if my initial velocity is negative, that refers to me throwing them down. If my initial velocity is positive, like it is in this problem, I'm starting by launching them up. Hopefully you enjoyed this instructional video about projectile motion things. Enjoy the rest of your evening.